So we're going to define fractions. Start from the very basic, okay? So what are natural numbers? Natural numbers are numbers like 1, 2, 3, 4. 0 is not a natural number. What are whole numbers? Whole numbers are basically the set of natural numbers plus 0. 0, 1, 2, 3, 4. What are integers? Integers are basically 0 plus minus 1 plus minus 2 plus minus 3, and it goes on and on and on. Okay? Rational numbers or rational numbers or fractions are basically an integer divided by another integer, but the denominator integer cannot be 0. Let's define it formally here. So let me actually put it on a different slide. Excuse me. Rational numbers are fractions where you take an integer and divide it by another integer. You just want to make sure the integer that you're dividing by is not 0. So examples of rational numbers are 2/3, 3. It's a rational number because the denominator is 1 in this case. And this is a rational number. Okay, this is a rational number. You can write it like this. I'm going to put the negative sign here. This is another example of a rational number. Okay, these are examples of rational numbers. We're going to use the word fractions more. All right. So, of course, the top number is called the numerator. The bottom number is called the denominator. Okay, proper fractions. Okay, proper fractions are fractions where the numerator is strictly smaller than the denominator. What are improper fractions? Improper fractions are fractions where the numerator is larger than or equal to the denominator. So please note here, 3 is greater than 2, so 3 over 2 is an improper fraction. Same reason holds for 5/3 or 5 over 3, 9/4 or 9 over 4. What about 2 and 3? The numerator is 2, and the denominator is 1. So the numerator is strictly larger. So 2 is an improper fraction. 3 is an improper fraction. Keep that straight. Okay. Of course, they're also called whole numbers. What are mixed numbers? Well, mixed numbers are numbers that have a whole number part and a fractional part. The first example you see here is 1.5. The second one is 1 2/3. And the third one is 2 1/4, or 2 1/4. All right. Another thing we'll kind of use a lot is this concept. Let me see if I can make it a little smaller. See, I don't even know how to do it, but I'll find out. All right, guys. So I took a pizza. I cut it into 3 equal parts. Each part is 1/3. And what you want to see is that 3/3, 1/3, 1/3, 1/3. When you take a third 3 times, you get the whole pizza back. It's a concept we're going to use a lot. 3/3 make a whole. 4/4 make a whole. Take a pizza, cut it into 4 parts. Each part is going to be 1/4, and 4 of them will make your whole pizza back. And you can guess 8/8 make a whole, right? And you can see it. Okay, this is a nice uh, thing to see. On the very first line, I have 1 whole. Let's say these are candy bars. On line 2, I have 2 halves. 2 halves make a whole. On line 3, I have 3/3, 1/3, 1/3, 1/3. They together make a whole. On the fourth line, I have a quarter 4 times. So if you take one whole candy bar, cut into 4 parts, you're going to get 4/4. Now let me take this so that I can write a few things on it. Give me 1 second. All right. So what's important here? What's important here is to see that 1/2 is smaller than 1, 1/3 is smaller than 1/2, 1/4 is smaller than 1/3, 1/5 is smaller than 1/4, so on and so forth. Now, another thing you can say is 2/3 is bigger than 1/2, 3/4 is bigger than 2/3. Let me show you one example nicely. Take a look. This is 3/4, and this is clearly smaller than 2/3. 1/3 and 1/3 make 2/3. Okay, let me change the color. Let me make it something like this. This is 2/3. And let me change it to this little dot. These dots are 3/4. 3/4 is bigger than 2/3. And you can help students see how fractions relate to one another using this wall chart called fraction wall. All right, moving on. All right, so this is a nice slide. So it helps us see that 1/2 can be represented in a variety of ways. In the first picture, I have 1/2, which is 1/2. Then I take, let's say it's a candy bar. I took the candy bar and cut it into 4 pieces. I had 2 of them. So I had 2/4, but that's also same as 1/2. In the third picture, I took the same candy bar, cut it into 8 pieces. I ate 4 of them. So I ate 4/8, but I really ate half of the same bar. So 1/2, 2/4, and 4/8, they represent the same amount. You want students to see it. This is very similar, and I'll let you think about it, how 1/3, 2/6, and 4/12 represent really 1/3. It's a visual way of seeing it. So here, guys, we're going to represent fractions in a variety of ways. When we represent fractions like this, with some people call it bar diagrams, area model, it's called an area model. And I'm trying to represent 2/3 here out of 3 rectangles. 2 of them are blue, 2/3 of the rectangles are blue. The next one, we can represent the same 2/3 using a ribbon or a linear model or a number line model. Same thing, 2/3 is 2/3. The third model is called the discrete model. I call it the cookies. So 2 of the cookies are chocolate chip cookies, 2/3, 2/3. So you can represent fractions using area model, which is probably the most common, then using the linear model or the discrete model. You're going to see these notes in the notes folder, so don't worry too much. I'm not going to go over every single example. So here is a good problem, guys. How do we convert 1 3/5 to improper fraction visually? Of course, we know how we do it mathematically. We multiply 5 by 1, we get 5, then we add 3, we get 5 plus 3, 8. 8 divided by 5 is 8/5. But how do we do it visually? So let me show you how it can be done visually. And why do we want to visually? Because we want to know how to do things in multiple ways. Why? Because we are teachers. We're dealing with a large number of people, so we want to know how to do things in multiple ways. Let me take this to a place where I can write. All right. So guys, let's say I have 1 3/5 of a second pizza. I have one whole pizza. I'm going to cut it into fifths. 1, 2, 3, 4, 5. And here I have 3 of the 5 slices. So clearly I have one whole pizza and 3/5 of a pizza. Now, basically I'm asking based on my denominator, which is 5, how many fifths are here in total? Well, let's count it. There is 1 here, right? I'm going to put some black dots. 1/5, 2/5, 3/5, 4/5, 5/5. Now this is a no-brainer, right? 5/5 make a whole, and then I have more. 6/5, 7/5, and finally 8/5. 1 3/5 is equivalent to 8/5. So my answer is 8/5, and I have a nice visual representation on the left. That's a good way to help your students see why 1 3/5 is same as 5/5. Another way to see it, you can say, my denominator is 5, so everything has to be in fifth. One whole has 5/5, and 3/5 have 3/5 in it, right? 5/5 plus 3/5 is 8/5, so the answer has to be 8/5. Okay, let's try this one. This one is the opposite. I have an improper fraction, 6/5, and I want to represent it as a mixed number. So my question is convert, don't worry about the bottom part, okay? This is the answer. This is the answer. So that's my question, okay? Don't worry about the bottom part. So the question is, how do I convert 6/5 into mixed numbers? But we all know how to do this. We can say 6 divided by 5 . So 5 goes into 6 once, and 5 times 1 is 5. And we subtract 5 from 6, and we get a 1. And so the answer is this quotient 1. And then the remainder 1/5. Of course, we know how to do it that way, and there's nothing wrong with it, but I'll try to explain it visually, okay? So why? Because again, we want to know how to do things in multiple ways. Some kids will like it mathematically. Some kids will like it when you do it visually. They'll understand things better. So guys, I'm going to pretend these are 1/5, and altogether I have 6 of them. 6/5 mean 6 copies of 1/5. But I do know if I collect 5 of the fifths, 5/5 make a whole, I'll get 1 whole. So instead of 5/5, I'm going to replace 5/5 with 1, and I still have 1/5 left, so the answer has to be 1 and 1/5. Here is a visual way to explain why 6/5 is same as 1 whole and 1/5. Okay, so here again, what we have here is a 3 by 4 rectangle. So if I want to represent 2/3, anything with a denominator of 3, and anything with a denominator of 4. This technique, let's make it 1/4. Okay, let's say I want to represent 2/3 and 1/4 using the same whole. This technique of drawing a 3 by 4 rectangle will come in very, very handy. We can use the same shape to represent 2 fractions, and this allows us to compare 2 fractions that are unequal or that don't look too comparable, very manageable. For instance, if I have a rectangle cut into 4 long strips, each strip is 1/4, and I take the same rectangle, cut it into 3 horizontal strips. Each strip has to be 1/3. So if I'm now supposed to shade 1/4, I'm going to do it like this. So let's make a copy of this. On the same picture, if I'm supposed to shade 1/3, I would do it like this. And I really want to compare 2/3 to 1/4, so I have to do it 1/3 plus 1/3. That's 2/3, right? Now I can easily see that 2/3 is much bigger than 1/4. It's a good way to compare two unequal fractions that have different denominators. All right. I can give you a question like, excuse me, I can give you a question like a plot of land. Two identical plots of land were given to two siblings. One sibling got 1/4 of plot A. Let's say this is plot A. And another sibling got 2/3 of plot B. Let's say plot A and plot B are identical. Okay. Who got more? Clearly, the person who got 2/3 of plot B got more. Another question could be your brother and sister received two candy bars, two identical candy bars. Your brother gave you 1/4 of his candy bar, okay? And your sister gave you 2/3 of her candy bar. Who gave you more? How much more? Clearly, your sister gave you more. She gave you 2/3, which has like 8 bits, and your brother gave you 3 bits. Your sister gave you a lot more. So it's a good visual way to understand or compare fractions.